Hi, this is Selvapriyan. Today let's see 2008 Transportation Engineering 2 mark questions. So first question, a roundabout is provided with an average entry width. So average entry width, this is E 8.4 meter, width of weaving section. So W 14 meter and the length of weaving section between channelizing islands as 35 meter. So this is L. The crossing traffic and the total traffic on weaving section are 1000 and 2000 passenger car unit per hour respectively. So the proportion of traffic will be crossing traffic divided by total traffic. So it will be 1000 divided by 2000. It is equal to zero point 0.5. And now the question is to find out the nearest rounded capacity of the roundabout. So capacity we have to find out. So capacity formula we know, that is 280 W into 1 plus E by W into 1 minus P by 3 divided by 1 plus W by L. So all values we have. W, it is width of viewing session 14 meter, and E average entry width, that is 8.4 meter. So P is the proportion that we have found out as zero point 0.5, and L length of viewing section as 35 meter. So all values are given. So it is a direct substitution. So the answer will be 3733.33 passenger car unit per hour. And in question they have mentioned nearest rounded capacity. So the nearest rounded capacity will be, it is 3700. Option B is the right answer. Next question, design parameters for signalized intersection are shown in the figure below. The green time for major and minor roads is given. So major road is from west to east. East west road is major road. So this is major road, and north south road is minor road. And vehicle per hour is given for both major road and minor road. The critical lane volume for on major road changes to 440 vehicles per hour per lane, and the critical lane volume on the minor road remains unchanged. So the green time will. So in question, in diagram, the values are clearly given. So for major road, it is 4 lane road. So it will be 2 lane on left side and a 2 lane on right side. So 660 vehicles per hour on left side and 500 vehicles per hour on right side. So it is for left side, it is 660. So left side there will be 2 lane because it is 4 lane divided. So left side there will be 2 lane and right side there will be 2 lane. So on left side for 1 lane it will be 330 vehicles per hour per lane, it will be 330, and for right side it will be 250 vehicles per hour per lane, it will be 250. On minor road it is 2 lane road, so it will be 180 vehicles per hour. On both the sides it is 180 vehicles per hour per lane. So per lane it is 180, because on left side there will be 1 lane, on right side there will be 1 lane only. And now the critical lane volume on the major road changes to 440 vehicles per hour per lane. So it is changed to 440 vehicles per hour per lane. From 250 it is changed to 440. From 330 it is changed to 440. So it is increasing. So the vehicle per hour per lane increases. So the change is increasing here on major road. On minor road it remains unchanged. So no problem for that green time. So for the green time on minor road will remain unchanged because the critical lane volume is as it is remaining unchanged. So the green time will also remain unchanged. So with that, the option will be either A or D, because only on A and D, the for minor road the green time remains unchanged. For on all other options it is changing. So for minor road it will be unchanged. Now regarding major road, so what will be on major road? Critical volume increases. So what will happen to the green time? It will also increase. So Obviously, option D will be the wrong answer. So option A is the right answer. As the critical lane volume increases, the green term will also get increased. If it remains unchanged, the green term will also remain unchanged. Next question. It is proposed to widen and strengthen an existing two-lane national highway section as a divided highway. So this is a two-lane national highway and it is divided. Existing traffic in one direction is 2,500 commercial vehicles per day. So this is existing traffic. The construction will take 1 year. So the construction, that is the widening and strengthening that existing highway. So it will take 1 year. It will take 1 year. The design CBR of soils upgrade is given, that is 5%. And now the traffic growth rate is also given. So traffic grows at a rate of 8%. So it is per year, it will be 8%. And vehicle damage factor, it is 3.5. Design life is 10 years. So the design life of that road will be, that national highway will be 10 years. And traffic distribution factor is 0.75. Now the cumulative standard axle. So we have already discussed this type of problem. To find out the cumulative standard axle. The formula is 365 into 1 plus r whole power n minus 1 and the ADF divided by r. So this is the formula. We have all values. So this is r is what, or it is what, that is traffic growth rate, that is 8%. It will be 0.08, and n is number of years, that is design life. So this is 10. So this is 0.08, that is 8%. So A is, this is commercial vehicles after construction. In question, it is given that this is existing traffic. Existing traffic in one direction is 2,500 commercial vehicles per day. So this is existing traffic. So we want the traffic after construction. So the construction period is 1 year. So A will be equal to 2,500 into 1.08, because the traffic growth percentage is 8%. It is given. So it will be 2,500 into 1.08. It will be 2,700. So A is 2,700. D is traffic distribution factor, that is 0.75, and F is equal to vehicle damage factor, that is 3.5. So after substitution, we will get cumulative standard axles as 37.47. So after substitution, it will be 37.47. So it is rounded off to 37. Next question. A linear relationship is observed between speed and density on certain section of highway. Free flow is observed as 80 km per hour. So free flow, it is BF, is given as 80 km per hour, and jam density is estimated as 100 vehicle per kilometer length. So it is kj, that is jam density, kj. Based on the above relationship, the maximum flow expected on the section and speed at the maximum flow will be. So maximum flow is, that is q max. Maximum flow formula we know, that Vf into kj divided by 4. So this is the formula for maximum flow. It will be 80 into 100 divided by 4. So this is 20 times, is equal to 2000. 2000 vehicles per hour. So either option C or option D. Now one more thing is asked in question, that is maximum flow will be. So maximum flow, that is maximum speed. Sorry, the speed at maximum flow. Speed at maximum flow will be, it is nothing but Vf by 2. Speed at q max is equal to nothing but Vf by 2, that is free flow speed divided by 2, that is 80 by 2, and it is equal to 40 km per hour. So option D is the right answer. So this formula, that is Vf into kj by 2, can be written as, this can be written as Vf into 2, Vf by 2 into kj by 2. So this is how that formula came. That is free flow speed divided by 2 into kj divided by 2. So Vf into kj by 4. Here Vf by 2 is equal to speed at q max, that is at maximum flow, what will be the speed, that is what Vf by 2, and kj by 2 will be equal to, this kj by 2 will be equal to traffic density. So this is traffic density. Next question. So two questions are asked in this problem. Single statement and two questions is asked. A horizontal circular curve with a center line radius of 200 meters. So R is given, is provided on two lane two-way SH section, that is state highway section. The width of the two-lane road is 7 meter. So two-lane width is 7 meter. So single lane width will be 3.5 meter. Descent speed is given, that is V is given as 80 km per hour, and brake reaction time is given as 2.4 seconds. So T is given, and coefficient of friction in longitudinal and lateral direction. On both direction it is given. First question is to find out the steps safe stopping side distance. So 84 it is stopping side distance. So it is Vt plus V square divided by 2gf. So V is given as 80 km per hour, converted into meter per second, that is into 0.278. And T it is given brake reaction time, it is 2.4 second. And this is coefficient of friction in longitudinal direction, that is 0.355. Lateral direction, where we use lateral direction for the calculation or super elevation. For super elevation we use lateral direction. Here we have to use longitudinal direction. So direct substitution. After substitutions we will get answer as it will be 124.35 meter. 124.35 meter. So it is rounded off to 125 meter. So this is S. S is equal to 124.35 meter. That is 125 meter. One more question, that is setback distance from center line of the inner lane. Center line of the inner lane. So, so this is a two lane road. So this is one lane and this is another lane. So this we will consider as outer lane. So this is outer lane and this is inner lane. So we calculate setback distance from the center of the road. So this is center. This is a road. This is state highway. We always calculate setback distance from here only. From center of the road, we always calculate setback distance. Now this will be 3.5 meter and this will be 3.5 meter, because in question it is given as the width of lane is width of here, the width of two lane road is 7 meter. So for one lane it will be 3.5 meter and another lane it will be 3.5 meter. So it is, as it is a multiple lane road, setback distance will be we have both two conditions. L is greater than S and L is lesser than S. Here length of road is not given. As length of road is not given, we assume L is greater than S. L is greater than 125 meter, that is S. So the formula will be R minus D cos alpha by 2. So this is formula. R minus D cos alpha by 2. So what is D here? So D will be this. So this is center line of outer lane and this is center line of inner lane. So the D is nothing but this distance. So D is equal to, so this is 3.7 3.5. So D is equal to 3.5 divided by 2. It will be 1.75. It will be 1.75 meter. So this is what D. Alpha is equal to S by R minus D. S by R minus D, it is in radians. So convert it into degree. S by R minus D into 180 degree by pi. So we have converted into degree. So here R is equal to given in question, that is radius 200 meter, and D we have found out as 1.75 meter. Alpha is equal to 180 200 divided by sorry, yes, that is 125. 125 divided by 180 minus 1.75 into 180 degree by pi. So we will get all other answers. So m is equal to, after calculation, m we will get as 11.52 meter. 11.52 meter. Here 11.52 meter is not in the answer, because not in the options, because it is not the answer, because in question they have told to find out setback distance from center line of inner lane. Center line of inner lane. So this is center line of inner lane. So always we will find setback distance from center of that road. Center of that road. So here they have told to find out center of, from center of inner lane. So it will be from here. So question, they have found, they have told to find out from here this distance. They have told to find out this distance, but we have found out this distance. So this will be, this distance will be, it is equal to m minus d. Required answer is equal to m minus d. So it will be 11.52 minus 1.75, 1.75, and it is equal to 9.77 meter. 9.77 meter is the right answer. So option D is the right answer. So setback distance, that is m from center line of inner lane is equal to m minus d. This we can write as, this we can write as setback distance. Setback from center line of inner lane is equal to m minus d. If setback from inner edge of pavement, inner edge is equal to m minus 2d. So what is inner edge? Inner edge is nothing but this is inner edge. So this is inner edge. Now again, center setback from center line of outer lane. They are told to find out from center line of outer lane. It is nothing but m plus d. M plus d. And setback from outer edge is equal to, you have already guessed it, that is m plus 2d. So outer edge is nothing but this one. So this is what outer edge. So that's it for today's video. Tomorrow let's see 2009 transportation engineering problems. Thank you.